Welcome to Understand the Math. In this problem, we're given a vector y and a vector u, and we're asked to do three different things. The first thing that we're asked to do is to compute the orthogonal projection of y onto the line through u and the origin. In part B, we're asked to compute the distance from y to the line through u and the origin. And then in part C, we're asked to write y as the sum of two orthogonal vectors. One is in the span of u, and one is orthogonal to u. To help us visualize this problem better, I went ahead and I graphed down here on the right our vector y and our vector u. So what's going to happen is we're going to take our vector y in blue, we're going to project it onto our line right here through our vector u and the origin. And then our vector in pink, that is our projected vector. And then we also then can create a vector, which I'm going to call z, that is orthogonal to our projected vector y hat. I had a student ask me the other day if when we do problems like this, we're always going to be given the graph. And the answer is no. When you do problems like this, you're not going to be given the graph, but I would recommend that you make your own graph so that when you find y hat, which is our projected vector, you can look back at your graph and see if it makes sense. We're going to start by computing the orthogonal projection of y onto our line through u and the origin. There's a formula for this, and it looks like this. We'll mark this as A. So y hat is our projected vector, and it's y dotted with u, all divided by u dotted with u, times u. Let's go ahead and compute this. Y dotted with u is going to give us a 15 minus a 40, and then u dotted with itself is going to be a 25 plus a 25, and that gets multiplied by our vector u, which is 5 and minus 5. Our y hat is 15 minus 40 is minus 25, and then 25 plus 25 is 50. So that's nice. That's just minus a half. And we have a 5 and a minus 5. We can write our y hat as minus 5 halves and 5 halves. Now let's look at our part B. For that one, we're going to compute the distance from y to the line through u and the origin. So let me go ahead and let's highlight this over in our graph. This is the distance that we're computing right there. That distance is going to be the magnitude of y minus y hat. So let's go ahead and let's compute y minus y hat first, and then we'll go ahead and take the magnitude. Y minus y hat is going to be our vector y, which we're given up top as 3, 8. And then we're going to subtract the vector that we just found, which was y hat, minus 5 halves and 5 halves. So this vector is 6 over 2 plus 5 over 2 up top. And then we can make this a 16 over 2 minus 5 over 2 on the bottom. And this gives us an answer of 11 over 2. And then 16 minus 5, another 11 over 2. Now that we have the vector, we can go ahead and find the magnitude. So the magnitude of y minus y hat is going to be the square root of 11 over 2 quantity squared plus 11 over 2 quantity squared. It's nice that it's the same thing. This is going to give us the square root of 11 squared is 121. So we have a 121 over 4 plus another 121 over 4. And this gives us the square root of 242 over 4. We can go ahead and take the square root of 4 and write that as 2. So our answer is going to be the square root of 242 all divided by 2. And that's the distance of the yellow line up there in our picture. Now let's do part C. We'll go back up and look at what that says. Part C says that we're going to write y as a sum of two orthogonal vectors, one in the span of u and one orthogonal to u. So let me make a note that our y hat right here, that is our vector in the span of u. And the reason that is that because y hat lies along the line through u and the origin, we can say that y hat is a multiple of u. So that means it's in the span of u. So this vector is going to be y hat, and then the vector orthogonal to y hat is going to be our vector z. So let's mark this as vector z. And we can see from our picture that vector z is equal to y minus y hat. We'll go back down here now and let's put part C down. So part C, we're going to write vector y as a vector in the span of u, so that's y hat, plus a vector orthogonal to u, which is our vector z. The first thing that we're going to have to do is find vector z because we already know y hat. So vector z, we're just going to get by taking y and subtracting y hat. We actually already found vector y minus y hat right there. And that was equal to 11 over 2 and 11 over 2. So all we have to do is basically just write down our answer. Our vector y is our vector y hat, which is our minus 5 over 2 and 5 over 2. That's our vector in the span of u, plus our vector z, which is our vector orthogonal to u, and that's our vector with the 11/2 in it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.